Hello everyone, today we are going to see class 10 exercise 1.2 third sum. Prove that the following numbers are irrational. So they have given you three irrational number. We are going to prove it one by one. So moving on to first sum, which is 1 by root 2. Okay. So first sum 1 by root 2 we are going to prove. So it is also same by contradiction method. First step as usual, let us assume that 1 by root 2 is an rational number. Okay, so first we are going to assume it is a rational number. So if it is a rational number, then what happens? So 1 by root 2 is equal to a by b, where a comma b are co-primes. Co-primes are nothing but the prime numbers which has 1 as its common factor, only 1. Okay, and b is not equal to 0, that is the denominator must not be equal to 0. Okay, so next 1 by root 2 is equal to a by b. So here now I'm going to reciprocal this 1 by root 2. If I reciprocal, I'll be getting root 2. Okay, if I do reciprocal on LHS side, obviously here also I have to do it, right? So b by a. Okay, so reciprocal is nothing but the numerator part should be denominator part and the denominator part should be in numerator part. That's what we will be saying at reciprocaling. So in an equation, if LHS is done, the same RHS must also be done, reciprocal. Okay, so we know that a comma b are integers. Yes, so integers. So b by a is rational, is a rational number, right? So b by a will be a rational number. So if the RHS of the equation is rational, then obviously the LHS will also be rational. So root 2 will also be rational number. But we know that root 2 is irrational, right? We have already proved root 2 is irrational. So if LHS side of the equation becomes irrational, obviously the RHS will also become irrational, right? So, but we know that root 2 is an irrational number. So this is contradiction to our assumption, right? So at first we have assumed that it is a rational number. Since the LHS becomes irrational, the RHS will also become irrational. So the whole sum, which is 1 by root 2, is irrational. So I can write this is contradiction to our assumption. So it is a opposite to our assumption. So I can write 1 by root 2 is an irrational number. Okay, 1 by 2 is an irrational number. At last we have to write hence proved. Okay, hence proved. So moving on to next sum. So we have done 1 by root 2. Now 6 plus 2 root. Okay, So 6 plus root 2. Same, we'll start with, let us assume that 6 plus root 2 is an rational number. So if it is a rational number, then it is equal to the P by Q form, which is A by B, where A comma B are co-primes and B is not equal to 0, right? B must not be equal to 0. So 6 plus root 2 is equal to A by B. Okay, so now I'm going to isolate this root 2 alone separately. So root 2 is equal to A by B minus 6. Okay, so I can leave as it is, or else I can also take LCM, like into B into B. So root 2 is equal to A minus 6B by B. Okay, so we know that A comma B and 6 are integers. So A minus 6B by B is rational number. Yes, since A, B, 6 are integers, obviously this whole RHS side of the equation will be a rational number, right? So if RHS side of the equation becomes rational number, obviously our LHS will also become rational. So root 2 is also an rational number. But we know that root 2 is an irrational number, right? Is an irrational number. So the whole question, that is 6 plus 2 root, is an irrational number. So this is totally opposite to our assumption, right? So where we have assumed it is a rational number, but here at last we found that it is a rational number. So it is contradiction to our assumption, which is nothing but opposite to our assumption. So I can write this is contradiction to our assumption. So hence 6 plus root 2 is an irrational number. Hence proved. So it is a proving sum. At last we have to write hence proved. Okay, so next our third sum is 7 root 5. Okay, now we'll see this. So third one, 7 root 5. Okay, so what is our first step? So it is nothing but, let us assume that 7 root 5 is an rational number. So if it is a rational number, then 7 root 5 will be in P by Q form, which is A by B, where A comma B are co-primes and B is not equal to 0, right? So 7 root 5 is equal to A by B. Now I have to isolate this root 5 alone. Okay, so what I can do, I can shift this 7 to RHS side of this equation, right? So root 5 is equal to A by 7B. Here it is in multiplication. If it goes to RHS, it will be in division, right? So root 5 is equal to A by 7B. Here A, B and 7 are integers, right? So A by 7B is an rational number. So it will become rational number. So fit in an equation LHS equal to RHS, where my RHS now it is rational number. Okay, so my LHS will also become rational number. So root 5 is also an rational number. Yes, but we know that root 5 is irrational, right? So at last, so since it is irrational, so this whole part will also become irrational. So I can write this is contradiction to our assumption where 7 root 5 is an irrational number. So it is totally opposite to our assumption. So at first we have assumed that it is a rational number, but at last, since root 5 has become an irrational number, A by 7B is also a rational number. So whole totally 7 root 5 will be an irrational number, right? So that's what we have proved here. So at last we should write hence proved. Okay. So once you have practiced this third sum for exercise 1.2, it will be better. If any other number have been given apart from the book question also, you can able to answer it. So that's it. Thank you.